Welcome to the physics class. In this lecture series, we will study about class 11 and 12 physics and also be solving ITJ mains and advanced problems. So the very first lecture is on chapter 1, that is measurement and errors. So I'll write it down: measurement and errors. So the very first topic that we are going to study is errors in measurement and least count. So when we have to measure an object, suppose this black object here, this object, then we use a scale on which the marking are from 0 to 10 in centimeters. So what is the least count of this scale? The least count of this scale is the least value that it can measure. In this case, it is from 0 to 1, that is 1 centimeter. So we have 1 centimeter here as least count for this object. Now what could be the maximum possible error in this object? So we can see that this object that we are measuring is just far from 7 and below from 8. So it can have we can take the value as 7 centimeters. So it can have the value of someone can take the value as 8. Some other person could have taken the value as 8 centimeter. So the maximum possible error that we can have in this object is 1 centimeter. So we can say that the maximum possible error is 1 centimeter. Now we will take another object and we will now measure it by a scale which has gradients in 1 mm. So we have this. So we see that this object is 1, 2, 3, 4, 5. 5 gradients away from 1. So it is the reading could be 1.5, or someone it could take the reading as 1.6. So the maximum possible error that it can have is 0.1 centimeter. So any figure that we have measured consists of two things. One is, suppose we have measured a quantity which has we have measured the value 6.24. Then we can have possible two possible values in this case. 6 and 2 are certain. 6 and 2 are certain, and 4 is uncertain. Why I am calling 4 as uncertain is because if we look at this previous example here, we have 1 as 1. Everybody will take the measurement as 1, but someone could take at 5 the digit 5 as 6. So this value 6 is uncertain. So we take the 4 digit. This digit is uncertain. So how many significant figures are there in this measured quantity? 6.24. We have three significant quantities, 1, 2, 3, in which 6 and 2 are absolutely certain and the uncertain digit is 4. Now, what is significant figures? I have talked about least count here. Now, what is significant figure? So, significant figure in a measured quantity, significant figures are the digits which are absolutely correct plus the first uncertain digit. So, we have 6 and 2 as certain and 4 as uncertain. So, we have in total certain plus uncertain digits that is 3. So, how many significant figures are there in this measured quantity? It is 3. Now, what are the rules for counting significant figures? What are the rules for counting significant figures? So, all the non-zero digits are significant. So, if, for example, we have, we will take the number 6 point, or we could take 126.28. We have 126.28. So, in this we have significant digits. Significant digits are 5 because all are non-zero. Now, second rule states that the zeros appearing between two non-zero digits are significant. So, 7.02, 7.025. So, the zero appearing between two non-zero digits are significant. These are non-zero. This is non-zero, non-zero, non-zero. So, this must be significant. So, we have 1, 2, 3, 4 significant digits. Significant digit as 4. Now, the rule 3 states that trailing zeros after the decimal places are significant. So, we have the number, suppose 6.400. 6.400. So, in this we have a decimal here. So, that zeros after the decimal would be significant. So, significant digit are 1, 2, 3, 4, 4. Rule 4 states that the power of 10 are not counted as significant figures. So, suppose we have a number or measurement as 1.5 into 10 to the power minus 8. 1.5 into 10 to the power minus 8. Then we have significant digit as here, this 2. This 10 to the power 8 won't count anything. So, we have significant digits as 4. Sorry, not 4, 2. Significant digits are 2, that is 1 and 5. Now, rule 5 states that if a measurement is less than 1, then all zeros occurring to the left of the last non-zero digit are not significant. So, suppose we have the value suppose we have the value so suppose we have the value this rule number 5 states that if the measurement is less than 1, then all zeros occurring to the left of the last non-zero digit are not significant. Suppose we have 0.0042, then the zeros occurring to the left of the last non-zero digit. What is the last non-zero digit? It is 4. So zeros before 4 are not significant. So we have significant digits as 4 and 2. Significant digits are 4 and 4 and 2. Now, rule number 6 states that change in units of measurement of a quantity does not change the number of significant figures. So, suppose we have 7.2 centimeter. 7.2 centimeter. Then, in meters, it is 0.072 in meters. In kilometer, it is 0.000072 kilometer. In nanometer, it would be 7. This multiplied by 10 to the power 9. So 7.2 into 10 to the power 7 nanometer. This n should be small. So all these numbers have two significant figures. So the change in units does not change the significant figure. Now rule number 7 is the terminal or trailing zeros in a number without a decimal point are not significant. This also sometimes arises due to change of units. So suppose we have 264 meters. In centimeters it has three significant figures. In centimeters it is this, but the trailing zeros, because it doesn't have a decimal point, so the trailing zeros are not significant. So this is a three significant figures. In mm it would be 264,000. Significant figures are not, these are not significant figures, so we have just 264 as significant figures. Rule number 8 states that exact measurements have infinite number of significant figures. Suppose we have one basket of bananas, or we have 46 students in a class. 46 students in a class, or the value pi, which is 22 by 7. So all these values are exact measurements. They are exact. So they have infinite number of significant figures. So that was all for today, guys. If you have liked the video, please do subscribe to my channel, like the video and share the video. And if you have any suggestions, please do comment in the comment box below so that I can improve on my further videos. Thank you.